From the Lorentz transformation we know that x prime is equal to x minus vt upon square root 1 minus v square upon c square. T prime is equal to t minus xv upon c square upon square root 1 minus v square upon c square. Here we have defined ux and ux prime, that is equal to dx upon dt and dx prime upon dt prime. So we know that what is ux and what is ux prime. So how to derive these ux and ux prime? That basically comes solved from the Lorentz transformation by differentiating this coordinate, this relationship of x prime and t prime. So x prime is equal to x minus vt. Differentiation part of it can be written as dx prime is equal to dx minus v dt upon square root 1 minus v square upon c square. And here t prime, that can be written as dt prime is equal to dt minus dxv upon c square upon square root 1 minus v square upon c square. So one can write now the ux prime, that is defined by dx prime upon dt prime. And now you have to put the value of dx prime and dt prime by taking here. So dx prime is equal to this dx minus v dt, right, and dt prime is equal to this one. So when you will put this value of dx prime and dt prime, this factor cancel out and you will get this thing, dx minus v dt upon square upon this dt minus dxv upon c square. Further what you have to do, you have to just take out the dt common, take out this dt outside, so this become dx upon dt minus v, and from here dt take out, so this dt and this dt cancel out, so here will be 1 minus dx upon dt into v upon this c square. We have already defined this dx upon dt is what? That is ux, right, that is ux, velocity component along the x direction according to the observer O. So you can write here ux prime is equal to ux minus v upon 1 minus ux v upon c square, and ux is equal to ux prime. This is in inverse by using the inverse Lorentz transformation. If suppose you have to find out the value of ux, then that will be ux prime plus v upon 1 plus ux prime v upon c square. In this mathematical formulation, how basically you derive the result for ux prime? You know that we have a frame of reference. Everything we are defining by using the frame of reference. So I will try to make this concept again clear here. This is our S frame, that is a stationary frame. A coordinate of this x, this is z, this one is y, and observer is here. So this is our frame of reference in which O observer is at the center, and this is denoted by S. Another frame, that is a moving frame, denoted by S prime, has the coordinates x prime, z prime, and y prime. This S prime frame is moving along the positive x axis along this direction with the relative speed v. This v is relative speed with respect to this stationary frame, right? So O prime is here. So one can define any event here P. If that event has to define by the O prime observer, that will be x prime, y prime, z prime, and t prime. And if this event has to define by the O observer, that will define this coordinate in this event in his coordinate x, y, z, and t, right, in his frame of reference. So this is the basic idea. And now the point is, suppose there is a particle or any other object is moving in forward direction with respect to the O prime observer. So this is that object. You can say it any particle or any object. This is in S prime plane and moving along the positive axis, moving a forward direction, right, in this positive axis. So this is the point about this particle or object. So one can find out the velocity component, right, for this particle. That will be ux prime, uy prime and uz prime along x-axis, y-axis, z-axis. So this for this particle that is in free space, and now we have made assumption that this is in forward direction towards the positive direction. So one can find out these component of the velocity ux prime, uy prime, uz prime. Why I have considered here prime plane? Because this particle is in s prime plane and moving into the forward direction, that is the positive x direction, and ux prime is the according to the O prime observer. If I have to find out the velocity component according to the O observer, they will be ux, uy and uj, and one can find out these components with the help of Lorentz transformation. So as you have seen here in the earlier slide that I have find out here ux prime only and ux with the help of this Lorentz transformation x prime and t prime. So one can write x also, x is equal to x prime plus v t prime upon the spectra, and similarly t is equal to t prime plus x prime v upon c square. So in Lorentz inverse Lorentz transformation one can write these relationship, right? So here ux prime is equal to ux minus v, 1 minus ux v upon c square. So if I have to find out one of the important point to keep in your mind to solve the numerical problem is that if in the numerical problem I have to find out ux prime, then I will use this formula ux minus v 1 minus ux v upon c square. It means in numerical problem these two parameters are given, ux and v, and c we know that is the speed of light, v is the relative velocity, ux is the velocity of that particle according to the observer O. As I have mentioned here that ux will be the speed or you can say in terms of the component along the x-axis according to the observer O. So this is the point only. But if suppose you know only this formula ux prime is equal to ux minus v upon 1 minus ux v upon c square, right, and in the numerical problem you have to find out the ux. So don't try to rearrange the terms in this particular formula. If you have to find out the ux according to the observer O, the velocity component, then you have to use this particular formula. So don't try to rearrange this term that you have to find out ux, so rearrange this particular formula. Then you have to only use this formula, and this is derived by using the inverse Lorentz transformation. So if one have to find out the ux, right, don't put the value of ux prime v here, ux and v here, right? So make it clear that if you have to find out ux, then you have to use this formula, and if you have to find out the ux prime, then you have to find out this formula. You have to use this particular formula. right? Because these formulas are derived keeping in mind the relative speed of the object and observer. So this was the first point in this particular topic. Now I have already explained the basic fundamental of this particular topic by making that clip arts. I am repeating again that I have considered here these things, that a biker, a bike, and a building, a stationary object, and this man basically, this O prime observer, this bike, is moving frame, and the person is standing here, that is a rest frame. So now the point is, if you have the basic idea or the picture is clear, this particular picture is clear, right, that this is an observer O prime, this one is a moving frame, throw a ball, and here is a stationary frame standing on the across the road. So if these things are clear, you can generalize this picture to anywhere, right? There are v is the relative speed of the bike, ux prime is basically the speed of the ball, ux is the speed of this ball according to the O observer. If this point is clear, you can generalize this idea to anywhere, whether there are two spacecraft into this space, both are moving into the same direction or moving in opposite direction. So if suppose this person, the O prime observer, throw this ball in opposite direction instead of forwarding direction, it throw in opposite direction, then the speed ux prime will be positive or negative. Now the ux prime will be negative, and similarly for the O observer, this observer, if this rider, this O prime observer, is moving along the positive x direction and throw the ball in opposite direction, then the speed will be minus ux prime, and obviously that is speed will be considered as negative relative to this O observer. So one important point in this numerical problems. So I was saying that you can generalize this idea to anywhere, to the spacecrafts, to any rocket launcher, or anywhere, wherever you want to use this formula, you can use this concept, right? There is only one rider, that is in a moving frame, O prime observer. Second observer, this man throw a ball, right, see in his frame of reference, that is considered as ux prime. Here this man see this speed of the ball as ux. So you have seen earlier that there are only these two formulae, ux prime is equal to ux minus v, and other is ux is equal to ux prime plus v. It means there are only three variables, ux prime, v, and ux. If you know about these, you can solve all these problems. So now I am considering the numerical problem based on it, and keep in your mind that I have used here a basic example of a biker who is moving in positive x direction through a ball, right, in his frame in forward direction, and there is a person who is standing across the road, that is in rest frame. So this is my point, and this is the concept. On this concept I have to solve some numerical problems.